after we did this on Thursday, Friday, that Matt and I kind of taught that differently, but that's okay. There's more than one way to do lots of stuff, and it's kind of good to see more than one way. That way you can kind of pick, you know, what you like to do the best. Then I left off the direct variation problems, but it is part of the curriculum, so we do need to cover those, and it's not difficult at all. So I think that'll be an easy thing to put in today's material. Then we'll start the new material, which is solving systems of equations. That means when we have two equations, and we're going to be solving them by using different methods, graphing, substitution, and elimination. And then we'll also be talking about systems that, and we've already done this to a certain extent, that are inconsistent or dependent, and state the number of solutions, and also be able to state, and I didn't write this, but you need to be able to state not just the number of solutions, but the actual solutions. Some reminders. Test 3 is Wednesday instead of Thursday. The past couple tests have been on Thursday, but this next one is Wednesday, a week from this Wednesday. According to ACC rules, you must have a working camera and be using Respondus. I know we've had some issues with Respondus, so if that does happen and you can't use Respondus, you must be able to allow Matt or myself to monitor you via Zoom. So you have to have a working camera. If you do not have a working camera, then you won't be able to take the test, or you for sure will not get credit for it. So if ACC has tablets or iPads that they are checking out to people, so you need to, if you don't have a working camera, you need to get one. That's part of the agreement to being in this course. And there should be no reasons you don't have a working camera. Okay, so the first thing I wanted to do, because as I was grading the homework, I noticed a lot of people not doing this correctly. So I would like to go ahead and do a piecewise function with everybody. And this is just, this problem is not part of the notes or part of the homework. I just pulled it up as an example type of problem. So I'm going to give y'all a minute to copy that down. And if you have graph paper, that's great. Otherwise, you can freehand this. It's pretty easy because it's all lines. But copy that down and start it, and then we'll go through it together. Remember that if you've got a less than or equal to, that means you've got a closed dot. If you just got a plain less than, that means you have an open dot. So anything that doesn't have the equal to symbol on it has an open dot, and anything that has the equal to symbol has a closed dot. Some of y'all did this beautifully, but a lot of y'all did not do it well. So that's why I want to go over this. If you don't like the way I'm doing it, you prefer another method, that's fine, just as long as you're getting it right. Now, because these are lines, you really only have to pull the endpoints, because it takes 2 points to determine a line. If they weren't lines, you would probably have to plot more points, because you would have to be able to determine the shape. That's why it's really good to know those parent functions, so you know, like an x squared looks like a u, or an absolute value looks like a v. So you can kind of get a feel for if you're doing it correctly. But the ones we're going to ask you to do will be linear. So they should, just plotting the endpoints should be, of each interval should be fine. So on this first interval, the first point is, for the x, is -5. And the last x on this interval is -1. And they both have the little equal to symbols with them. So they are both going to be solid dots. And so if I plug -5 into this equation for f of x, -5 minus 1 equals -6, and -1 minus 1 equals -2. So 2 points, the 2 points that I'm going to graph are -5, -6, and that's going to have a solid dot, and -1, -2, and that's going to have a solid dot. And I'm going to connect those points. So that's the first piece. That's why it's called a piecewise function. So then the second piece is this one. And the first point here would be the -1. And it would have an open dot because it has no equal symbol beside it, just has the less than. And then the second one would be a 4. And it has a closed dot on it. And then no matter what in this interval, every x value is going to be paired with a 5. So the 2 points that I'm going to use for this interval are -1, 5, and 4, 5. This one has an open dot, this one has a closed dot. And I connect those. That's a constant piece right there. And make sure that you have closed dots and open dots. I mean, it's more important, like if it's an open dot, make sure it looks like an open dot. Because if it's closed, this would not be a function because you would have 2 x values that are both paired with, an x value that's paired with 2 y values. So you don't want that. All right, so then the last interval, this one, goes from 4 to 8 with an open dot on the 4 and a closed dot on the 8. And 3 minus 4 is -1, and 3 minus 8 is -5. So the 2 points on this interval are going to be 4, -1, an open dot, and 8, -5 with a closed dot. So it would look like that. And that is discontinuous because you'd have to pick up your pencil to draw that graph. They're not connected. So this would be discontinuous. Okay. So if you missed that one, I would go back and pick some of the ones from the bookwork or even the one on the written work and do it again. Make sure you know how to do those. All right, then these are the problems that we did not do direct variation, but Matt did cover them in the notes because they were in the notes. A direct variation is a line that always passes through 0, 0, which is really the super easiest kind of a line because if you're given any point on the line, you know what the slope is. So for example, I have a direct variation that I know passes through the point like say 5, 2. Then I know the slope. If I know any point on a direct variation, I know the slope or the constant of variation because if you take y1 minus y2, anything minus 0 is just itself. So that would give you 2. And 5 minus 0 would be 5. So our k, which is the constant of variation, is just the same thing as the slope. And again, it's really the easiest form of a line because the y-intercept is the origin. So one method that I use is if y varies directly with x, So I'll say, okay, y varies directly as x. So that means y1 over x1 equals to y2 over x2. That's one method. And then the other method is to use the y equals kx, which scientists, or scientifically, I know a lot of my science friends would, when they'd look at what we were doing in mathematics, they'd go, what are y'all doing over here? Because they're usually using the proportions or the direct variation where you're just comparing the fractions. So the main thing that people mess up on is not keeping things consistent. So it says find y when x equals 5, if y equals 7 when x equals 14. So this is our y1 and our x1. So I'd say 7 over 14. And then we're trying to find x, so that's what we don't know. I'm sorry, that is what we do know. We're trying to find y. So, well, I'm just messing this whole thing up. This is exactly what I'm talking about. So if x equals 5, the x has to go on the bottom, and we're looking for y on the top. And then from here, we can do a cross product, and you can only do that if it's 1 ratio equal to 1 ratio. So I'm going to do a cross product, and I'll get 14 times y equals to 7 times 5. And so y would equal to 35 over 14, which reduces to, and I could have reduced that 7 over 14 to 1/2 if my brain was clicking a little bit better this morning. For some reason, the air pressure or something is making me a little bit dingy. So this would be 5 over 2. So that would be what y would equal. Method 2, we would say y equals to k times x if you're asked to find the constant of variation. Again, if you're asked to find the constant of variation, here you know a point on the line is 14.7. So the slope, or the constant of variation, is just going to be 7 over 14, or 1/2. So that's going to be y equals to 1/2 x. And then if you plug in, find y when x is 5, you would say y equals to 1/2 times 5, which is 5/2. Constant of variation is just the same thing as slope. The only difference between a direct variation and just any old linear variation is that we always know that direct variation passes through the origin. So here it says find the constant of proportionality, and this was one of the problems on the homework, k, and the undetermined value in the table. So we're looking for this y value if y is directly proportional to x. So they're telling us that y is directly proportional to x. So we don't have to figure that out. We don't have to do any kind of experimentation or look at anything, because we're being told that this is true. So we can pick any point we want to find the slope, because we know one point on the line has to be 0, 0. Has to be it, otherwise not direct variation, or directly proportional. So that's another thing. Directly proportional means the same thing as varies directly, means the same thing as is directly proportional to. So varies directly and directly proportional mean the same thing. So I'm going to find the slope by just putting any y over any x, because that's my k. So in this case, I'm going to say 7.5 divided by 3, but I could pick any of them. They're all going to be the same. If they're not, then they lied to you about this being a direct proportion. And that's going to give me 2.5. And so then I can say y, I'm looking for y, is equal to 2.5 times 8. And 2.5 times 8 is what? 2 times 8 is 20. So that's what would go here. Another way we could have done that is we could have picked any point and set it up with like 15 over 6 equals to y over 8, and then done a cross product, and we would have come out with exactly the same thing. Okay, so I'd like y'all to try this one.
I was gonna say the other thing that's like kind of implied when they say directly proportional is that like when your x variable goes up, your y variable is also going to go up.
Right.
So we'll talk about something later called inversely proportional, which is like if one goes up, the other one goes down. So there is something else.
Right. So
Maybe a few moons from now, though.
And that's really a good point, because if you look at this problem, and I'm hoping y'all are working on it right now, the cost of tuition is directly proportional to the number of credits. If 11 credits cost $720.50, find the cost of taking 16 credits. Well, you know then as 11 goes to 16, it's going up. So you would know that the cost would have to go up also. So if you wind up with something that's less than $720.50, you know you did something wrong. Yeah, I'm gonna call on someone, or do I have a volunteer to tell me what they did on this or how they're doing it?
I don't know if I'm right, but don't you have to multiply something?
Okay, tell me what to do.
With the, I don't remember.
Okay, there's a couple things you could do here. So tell me, if you know that 11 credits cost $720.50, what would be the point that would go with that? What would be the ordered pair that would go with that sentence? $11 credits cost $720.50. Can anyone tell me what ordered pair would go with that?
11 and so it would be 11, 720.50.
Thank you. Okay, and then it says find the cost of taking 16 credits. So what is that 16 in the second point? Is it the X or the Y?
It's the X.
It is the X. And we are, here I go again, 16 is the X, and we are looking for the Y, correct? So there's a couple things we can do from here. What do you think? Well, it says, what is the constant of proportionality? How can we find the constant of proportionality? It's easy. What?
Can we divide this?
Yeah, just take, it's just going to be what?
Y divided by X.
Yeah, just take the Y and divide it by the X, and that's it. Okay, so 720.50 divided by 11.
And then it equals 65.5.
65.5, great. 65.5. So that's our constant of proportionality. And what's another word for constant of proportionality? It's the same thing as. Anybody? What is the constant of proportionality? The same thing as?
Slope.
Thank you. It is the same thing as the slope. All right, so we found our constant of proportionality. So I'm going to scratch that off because we did that. And then it says, so we actually want to find this number, the cost. So there's a couple ways to do that. I would like someone to tell me what they got and how they got it.
I got, hold on. Cost would be 1,048. I did that by doing the cross product method that you mentioned.
Great. So tell me what to do.
So on the left side, I have 720/50 over 11. And on the right side, I have y over 16.
Okay, and then you just got 11y equals to what?
11,528 over 11.
Okay. Great. Anyone do it a different way? Okay, well, you could, either way is fine, just as long as you're coming up with the right answer. Does everyone agree with that answer? Any questions about that? Anyone disagree? And does it make sense? If 11 credits cost 720.50, would it make sense that 16 credits cost 1,048? It does make sense. So as long as your math is correct, it is logically okay. Okay. So this looks really, number 77 I think is funny because it looks like it's a hard problem, but it's really not a hard problem. I drew this, and my artwork I know is probably astounding all of y'all. Suppose a 15-pound weight stretches a spring 8 inches, as shown in my lovely figure. Find the spring constant. When they say find the constant, that means find the constant of variation, okay? So if we've got a 15-pound weight stretching a spring 8 inches, what would be the ordered pair that goes with that sentence? Anyone?
15/8.
Thank you. Okay. So what is the constant of variation, which is our K?
Eight over 15.
Thank you. Then it says, how far will a 25-pound weight stretch the spring? So once again, we can either use a proportion or we can use our constant of variation, whichever way you like better. I'm going to go ahead and just use the proportion. So I would say 8 over 15 equals, now here's where people mess up though. Where does that 25 go on the second fraction? Does it go in the numerator or does it go in the denominator? Numerator, why? We could cut off, but you are right.
Yeah, I would look at the units. If you write the units out, it makes a lot of sense.
Yes, pounds and inches. So here we have 15 pounds and 8 inches. So we know that 25 pounds has to go in the bottom. X inches. And that's where people get mixed up.
Because if I'm being honest, you can flip this thing, and I don't even know what direction they usually write the equation in. To be honest,
Right. It doesn't matter, right? You could put the pounds in the top and the inches in the bottom. It doesn't matter at all. But because you could flip the inches and the pounds, right? They could say if you have an 8-inch spring and you attach a 15. If you have a spring and you attach 15-pound weight, it stretches it. How would you say it where it was inverse? Anyway, it really doesn't matter which way that you put that.
I just meant like the way that you set up the fraction. You could go 15 to 8, and then you have to go 25 to X.
Right. Well, that's what
you have to compare inches to inches and pounds to pounds.
Right. Exactly. And I was trying to, yeah. but that's what you would do. So then we would get 15x equals to 200. So x is going to be 200 over 15. Which is 13 1/3. And then another thing I'd like to caution y'all on is make sure you put the units. And if it says like some things that people were missing on the homework, it would say we're talking about 50,000 gallons. And in the end, you would just tell me like 75. You need to tell me not only 75, or some people would put 75 gallons, and it's actually 75,000 gallons. So make sure that you get the units right, and also the denomination. Okay, so now what I want to do is start the homework for today, the book exercises, and I want to just do a quick example of each type, and then after we do that, I'm going to put y'all in groups and let y'all work on the rest of them, and then we'll come back and check them. All right, so the first one on the homework from the book work is number 1, and it says, in the following exercises, determine if the following points are solution to the given system of equations. So generally speaking, unless you have 2 lines that coincide or don't intersect at all, you're only going to have 1 point. So if you find like if A works, then you don't have to even check B. And if A doesn't work, check B and see if it works, and if neither of them might work. But when you're doing the homework, please show your checks. I can't tell you how important that is, because if you're like me anyway, I mean, the checks have saved me a million times in my life. So I really want you to check your work. It's not that much to do. So here, -5, -7 has to work. I'm using number 2, which is actually not on your homework, but I just want to show you what they're wanting you to do. They want to know, is this a solution to this system? In order for it to be a solution, that means it has to fall on both the lines. So that means that it has to work in both the equations. So I'm going to test the first equation first. So let's say -3 times -5 plus -7, does that equal 8? And that would be 15 plus -7, does that equal 8? And it does. But we're still not through, because not only does it have to work in the first equation, it also has to work in the second equation. So I'm going to say, does negative of -5 plus 2 times -7, now I'm working with this equation, equal to -9. And that gives me 5 minus 14, or plus -14. Does that equal to -9? And it does. So I found the 1 point that is on this. Now, unless these, it is possible, and so I really shouldn't have said you don't even have to check the other one. It is possible that these 2 lines could coincide. So usually, a lot of times you can see that if they will or they won't, but I can't at this stage. So I'm going to go ahead and check the second one as well. So I'm going to plug -5 into that first equation. Well, I already know -5 works, right? So I don't need to worry about that. Let's try 7, because I already checked -5. It worked in both of them. So I'm going to check 7. So I'll say, does -3, oh no, never mind. -3 times -5 plus 7, does that equal to 8? And that would give me -15 plus 7. Does that equal to 8? And it does not.
I think you dropped off a negative on that 5. It should be -5, -3. It still doesn't work.
Oh, there we go. Yeah, still, thank you. You're going to have to watch me today. I'm having a feeling that it's going to be one of those Mondays. 22. So it doesn't work. So that one doesn't work. So it's just basically showing you how to check your work. Okay. Solve the following equations by graphing. Okay, and I do want to show y'all, I want to show you something because you can use this on the test if you want to. Just a second. If you have the, we're allowed to share the, well, can they get that? That's what I'm confused about. We can share the TI-84s with y'all, but can they use that on the test? Can they, Matt? How would they do that? I guess not.
What do you mean? Oh, the.
Yeah, I was going to show them that because they can't use Desmos, but because remember they shared that program with us, but now
I know there's a calculator on the test, but I don't know.
Yeah, I'm thinking never mind. I'm not going to show that because I don't think you can do that. So we'll just go straight from here. So here you're just going to graph these, and I'm not going to show you how to do that because y'all know how to graph. And then wherever they intersect, that's going to be your solution. Okay. Okay. Oh, I guess I will show. I want to show one. So like on number 11, and this is from the homework. So if you want to do this along with me, that would be great. This is by graphing. This one to me, you can solve for y if you want, or this one looks like it would be good to do by the intercept method. So I plug 0 in for x, and that would give me, if I cover up the x, or just plug 0 in for x, that would give me y equals -4. So one point is 0, -4. And then if I plug 0 in for y, I get x is -4. So one of my lines is 0, -4, and -4, 0. Okay, in a minute I'll draw that line. Okay, then the second line, again, you could put it in y-intercept form, but this one's easy to do by intercepts. So one of the points, I'm working with this line, would be 0. And if I plug 0 in for x, I would get 2y equals -2. So y would equal -1. And then a second point, if I plug 0 in for the y value, I would get -x equals -2. So x is equal to 2. So 0, -1, and 2, 0. So this is where they intersect right there at -2, -2. And then I want to check my work. Does -2 plus -2, I'm checking it in this first equation, equal -4? Yep, it does. Does the opposite of -2 plus 2 times -2 equal -2? So that would be 2 plus -4. And it works also. So make sure you're checking your work. Show your checks. If you missed the problem and you haven't shown the check, you're going to get a lot more counted off than if you show your check. Because if you show your check, you shouldn't miss the problem. Okay, so the rest of those are going to be for y'all to work on. Okay.
Typically, we don't like go solving stuff by graph because your graph can be kind of off.
Oh,
unless you have like a calculator, then it's accurate, right? Or technology.
Yeah, these are all going to be nice though. They won't come. They'll all graph to be nice.
I'm just reminded, like every time someone tries to solve something by graph, I'm reminded of that infinite chocolate bar happening.
What is that?
It's like if you cut a chocolate bar, you can always get an extra little piece out of it. It's a little
Oh.
manipulation with the slope is always different, how they're cut. But if you know how to count slope, you can count the slope on that thing, and you can kind of figure out the gimmick.
Okay, so I also, before we break up into groups, I wanted just to really quickly go over types of linear systems and the different things that can happen. And I know this has been gone over, but I just want to refresh your memory on this. So there's the three things that can happen. The thing we really want to happen is that we just get two lines that intersect in one nice point. That's the most useful. Otherwise, it's kind of like, why do we just do that? So that's if the slopes are not equal to each other, then your lines are gonna intersect in a point, and you'll have a consistent and independent system, and that means there's gonna be one solution, which is really nice. Then the second thing that can happen is that the slopes are the same and the y-intercepts are not the same. And that means your lines are going to be parallel. And that's inconsistent. And we also call that an identity. And I don't care, and I don't think Matt cares which one you use when you're asked to identify. And the last thing that can happen is that the slopes are the same and the y-intercepts are the same.
Is that that's also considered consistent, I believe, right? Consistent and dependent.
And dependent, yes, it's also consistent, yeah. Right?
Yeah.
Yep, consistent and dependent, and I mean the words they start getting, yeah.
I'm not big on that vocabulary. I care more about like identity and.
Me too.
More that it has one solution, no solution, or it's the line over itself and it's everything on that line.
Yes, that's how I feel too. So basically it's like, so dependent just means that it's actually the same line. And so then there's different things like the classification. If you get an equation and the variables go away, in other words, there's no variable left. There's no x, no y, nothing left. You wind up with 0 equals 0. You can either tell me that's an identity, or you can say it is, or you can say that it is dependent. I don't care. Consistent and dependent. I don't know, whatever. The number of solutions would be infinitely many. But it does matter that, like, you can't just say, okay, infinitely many. That means 5, 8. That doesn't make any sense. So like, for example, here, there are infinite points on this line, but you have to make sure that you clarify, like the equation of this line would be y equals 2x minus 1. So the solution for this particular dependent system would be x comma y such that y equals 2x minus 1. So your solution set could look like x comma y. You could either, whatever equation you like, you could say ax plus by equals c if it was in that format, or you could say y equals mx plus b. You just have to put the line as part of this, as a solution set. It has to be an x and a y that satisfy that system, that line. Then if you get something that's like 0 equals 5, which is totally false, that's either, you could call that a contradiction or inconsistent because it's false. Number of solutions, there would be no solution. And then the solution set would just either be, you could write the null set, or you could write brackets that don't have anything inside of them. Okay, so that's, I just wanted to refresh your memory on that before we move on to the next ones in the book exercises. So it says, without graphing, determine the number of solutions and then classify the system of equations. So I just showed you what we're looking for. You're looking for either you'll solve it and you'll come up with a system that, like a true statement, in which case like a 5 equals 5 or a 0 equals 0, in which case that means that there's infinitely many solutions. Or you'll wind up with a false statement like 0 equals 5, and that would mean there were no solutions, or you'll wind up with one nice point. So that's what I wanted to discuss there. Okay, then solving by substitution. Usually, I don't usually solve by substitution unless it's super easy to get one of the variables by itself. Like on number 33, it would be really easy to get that x by itself and substitute in for x. On this example, it's almost solved for y. So this would be the same thing as y equals to 2x minus 2 if you multiplied that whole equation through by -1. And then substitution just means go into the second equation or the other equation and substitute in that y value. So this would be 5x minus 3 times 2x minus 2 equals -1. And then solve for x. So this would give me 5x, distribute the -3. That would be minus 3x plus 6 equals -1. And then that would be 2x. And then subtract 6 from both sides equals -7. And divide both sides by 2. And we would get x equals to -3.5, or you could leave it -7/2. And then you want to know what y is. So y equals 2 times your x that you just got, minus 2. And that would be -7 minus 2, which is -9. So the solution would be -3.5, -9. And then you should check your work, but I'm not going to right now because I want to give y'all time to work here in a minute. Okay, then the last type of problems is by elimination. I'm going to do number 53, which is actually one of your homework assignments. Pick an x and a y, x or a y, and decide you want to get rid of that. And what you have to do to get rid of that is to have the same number but opposite signs. So I choose, and you can choose whatever you want, but I'm going to choose to get rid of the y. Now the easiest way, or an easy way to do this, is whatever is in front of the y here, you're going to multiply this by that, the second equation by that number. And whatever is in front of the y here, you're going to multiply that by the other equation. But we also have to take into account the sign. And both of these are positive so far. And we want one to be positive and one to be negative so that when we add the equations together, it eliminates. So I'm going to go ahead and let this be a -5. And I'm going to multiply that -5 through every single piece of this first equation. And that's going to give me -55x minus 45y equals to 25. And then I'm going to multiply everything in the second equation by the 9. And that's going to give me 63x plus 45y equals -9. And see how nice this is because now these guys, when you add these together, the negative 45y and the positive 45y will cancel out. So I have negative 55x plus 63x, which is 8x, and 25 minus 9 equals 16. I get x equals to 2. Then I can plug this number back into either one of my earlier equations. I'm going to pick the second one. It just looks nice and easy. So 2 times 2 minus y equals 2. 4 minus y equals 2. Subtract the 4. Negative y equals negative 2. So y equals 2. And so I get 2, 2 is my solution. And again, to check that, you would want to put it into the equation you did not use. So I used this equation to find the y value. So to check it, I'm going to check it in this top equation. So I'm going to say, does 5 times 2 minus 3 times 2 equal negative 1? And it doesn't. So what did I do wrong? 10 minus 6 is not negative 1.
Are we doing 53 or 49?
What?
You're using an equation from 49, but I thought we were doing 50.
Oh, thank you. There we go. So, yeah. So anyway, I'm telling you, sometimes you guys, you have to really watch me. I have my senior moments. So did I plug that? Okay, no, okay. So I should have plugged it into this. Yeah, I was plugging it into the totally wrong equation. Sorry. No wonder it's not working. Should have plugged it into this one. Okay, and so then that would have given me, sorry about that. Disregard all of that. So that would have given me 7 times 2 plus 5y equals negative 1. So that would be 14 plus 5y equals negative 1. 5y equals negative 15. So y equals negative 3. And then, so my answer should have been 2, negative 3. And then to check, plug it back into this equation, and it should check, hopefully. Okay, so I'm going to put y'all into groups for about for a few minutes, and in about 15 minutes we'll come back and compare answers. And Matt and I will, if you're having an issue or a problem, just let us know and we will pop in to your group, or we'll pop in anyway.
Which problems do we work on?
So it's the ones, these, except for we've done a few of them already.
Okay.
Okay.
What are you working on?
Problem 7.
Working on number 9.
Oh, it's graphing.
So since the y-intercept is 0, 2 for both equations, that would be the solution.
What are you going to put the solution?
Since the 0, 2 is the y-intercept for both equations, that would be the solution, right?
Yeah, that looks like it. Nine, 11, what'd you say, 17? Oh, it's just a bunch of graphing. Any questions about any of these? It's like just a lot of graphing mostly, huh?
Yeah, so far so good.
You have to solve these, huh, for y.
Yeah, this number 17, I was kind of stuck because when you try to solve the first equation for y, you divide by,
So what kind of lines are those? Is that right?
I meant number 21, sorry.
Oh, okay.
Number 21, when you try to solve for y for the first equation, you're dividing by 3, so you end up with 4 over 3 for the y-intercept.
X equals minus 3y plus 4. Grab. Let's stop this. And let's get to save. No? Okay. Okay. You're connected here. Let me connect my camera. There we go. So if you're solving this for y, is that what you're saying? X equals minus 3y plus 4. There's a few ways to do it. Subtract the 4 over. And he said divide by minus 3. So if we divide by minus 3 each side, this would be minus 1/3 x, and this would become positive 4/3.
How do you graph that?
What was that?
So to graph the 4/3,
Oh man, they can make you graph that? Yeah, that's a pain in the ass. I don't know what to tell you there. It's not fun. I don't know. Try to get it close enough. For this one, are they parallel? They might be parallel, so it may not matter too much as long as you draw them parallel. But don't definitely check what I just said. I didn't look. 2x plus 6y. Solve that. I think we'll get negative 1/3 slope. Looks like it. Subtract 2 divided by 6, that'd be a third. It might be the same line. I don't know. Anything else giving you a run for your money on this thing?
Yeah.
All right, I'm going to bounce around then, I think. Where else can I go? Who else can I bug? Where'd she go? I don't see where she is. Did she disappear? Huh? Didn't see that.
Nice.
Are y'all getting this? Are you graphing
Yeah,
it?
well, right now we're working on number 11 and graphing it.
I don't want to do that for. There we go.
All right. Real quick, everyone, for the ordered pairs, for the y equations, I got y equals 1, negative 2, plus 1. And for the second equation, I got y equals negative 1 over 1 minus 4. Real quick, anybody get anything different?
I'm still doing it.
Take time. All right.
A lot of graphing, huh?
Yeah, sadly.
You said -2, -2
Sorry?
for the ordered pairs for number 11.
No, I was writing out the equations.
Oh,
Yeah. But I believe Negative 2, 2 is the correct ordered pair. Did anybody get any equations? Guess not. All right.
I think you said the right thing. Y equals what? Negative x minus 4?
Mm-hmm.
Yeah, that's it.
I got, and for one of them, for another one, I got y equals 1 over negative 2 plus 1. I think I got one of these equations wrong.
Y equals, it should be a half x.
Yeah. Positive or negative?
It should be positive because when you add the x over, it should become positive.
Right. Oh, crap, man. I put the, dang it. I wrote the negative 2 on the bottom when I was dividing, darn it. Yeah, it shows, yeah, it's positive 1 half x. Makes so much more sense. And then, yeah, y equals 1 half plus 1. That's what I got.
It should be minus 1.
Minus 1? Oh, dang it. Yeah, you're right.
There's a positive 2 on that y. I don't know if that's...
Yeah, there's well, below it, I wrote minus 2y, and then minus 2 across, and then I had to cross that out, but I read the wrong equation. Okay. Minus 1. Now this is making sense. Okay. Here we go. Okay. Has anybody completed number 17? Nope. Well, for anyone who's curious, for the y equals 1 half x, I added a 0 to that equation. Then I went ahead and solved for y on the equation above, and I got y equals 2x plus 1. Anybody get anything different?
I'm working that one out right now, actually.
Oh, okay. All right. All right. Glad I
Uh-oh. I guess we're going to leave this in a minute.
I'm sorry, my mom is talking really loud in the hallway.
Oh, no, it's all good. It's all good. Listen, it was really great working with you guys.
What was the slope on that first one you got?
Which one?
That first equation. You said y equals what?
1 half x, and I added a 0 for number 17.
Oh, yeah. That's the first one. And the second one?
The second one, I got y equals 2 over 1. All right, I'll go double check.
I think, yeah. Look at what order you're dividing those things in.
Yeah.
Yeah.
Oh, crap. It's 1 half.
Okay, so I think we're all back. I know that wasn't a whole lot of time to work on this, but I'm hoping that this is not going to be too much of a challenge for you guys. So I wanted to have a little bit of time to go over and
They gave him too much graphing on this one, I feel like.
I think so too. I totally agree. I think maybe they were trying to make a point. Like, this is what I'm thinking. And okay, so number 1, the first one, hopefully y'all got 3-1 worked. -3-4 did not work. Then I think the point that they were trying to make on this is like the first couple have nice solutions and then the last two, when you do them, one of them turns out to be parallel lines, so there would be no solution. And then the number 21, that would be the same line. So the solution would be whatever equation you choose to write for that line. So like on 21, I just used the point slope form of the equation, but you could also have said xy such that 2x plus 6y equals 8, or whatever you want, just as long as it's the equation of that line. So we only have 10 minutes, and I will post all of this. I will put all of this on Blackboard, but I think probably graphing the lines is not a bad thing. And I just for grins, I just want to show you if your equation is already in slope-intercept form. Just a second. Oh, I can't get it to share. Never mind. This is not working for me. You could put it into the calculator and find out where the intersections are. That's just what I was going to tell you. So that's a good way to check your work on those as well. Then 29, it says without graphing, determine the number of solutions. So how could we determine the number of solutions without graphing this and without even solving it really? What would we be looking for? So if they ask you to do it without graphing it, the easiest way to do it is just to, and there's many ways you can do this, just put it into y equals mx plus b form and look at the slopes and the y-intercepts. And if they are, so let's go ahead and look at this one. So we already have this one, and the slope here is 5/2, and the y-intercept is -5. So now if we take the 5x minus 2y equals 10, solve it for y, we would get -2y equals to -5/2, 5x plus 10, and then divide by -2. And we see that we have m equals 5/2, and b is also equal to -5. So what would, how many solutions would this have? If the slopes and the y-intercepts are exactly the same, they are actually exactly the same.
Infinite.
Right, infinitely many solutions. And to classify that, what would you say that those are? What kind of lines are they in relationship to each other?
Dependent or an identity, whatever you prefer.
Yeah, either one is fine. A dependent, you could say, or an identity. And then they didn't ask for the actual solutions, but you should be able to tell me that the actual solutions would be xy such that y equals 5x, 5/2 x minus 5. Okay, then solving by substitution. We did 33 and 45. All you would have to do on 45, and this is good practice for you, is take that -2/3 x plus 5 and plug it in for y. and solve that system that way. Did anyone do that one?
Yeah, I got no solution.
You got no solution on this one?
Mhm.
Okay, so let's just see if that's true. I'm glad you did that. So if we said 2x plus 3 times negative 2/3 x plus 5 equals to 11, then that would give us 2x minus 2x plus 15 equals to 11. And that would give us 15 equals 11. Yep. So that means there is no solution. And what kind of lines would that be if you were graphing them? What kind of lines have no intersection?
Oh, parallel.
Yeah, right, exactly. Good. And then solving by elimination. So again, we're not going to have time to do all of these, but did anyone do 61 or any group do 61?
Yeah, so I again got, this is a dependent, consistent line. Yeah.
So you're saying it's just the same line?
Yes, because I ended up with 0 equals 0.
Okay. All right. So tell me what you did.
Because I did the least common multiple. So the easiest one I found was 3x. So I worked off of that.
Okay. So you multiply the top one by 3?
Yes.
Okay.
And yeah.
And then if you add those together, you wind up with getting 0 equals 0. Good. And so that means it's dependent, consistent. You can also call that an identity. And what would the solution to that be?
Well, infinite solutions. It's the same
There's
line.
infinitely many solutions, right? Infinitely many. But then to actually state the solution, you need to put x, y, such that, and then you could pick either one of the equations, x minus 4y equals -1. That would be the actual solution. And then 65 says choose the most convenient method to solve a system of linear equations. So it didn't actually say to solve them, but I do want you to solve them. So what would be the most convenient method to solve this one? Do you think? It's totally arbitrary, but I mean, to me,
I think it's kind of leading a little bit though.
Yeah, it's very leading.
Yeah.
So what do you think, guys?
Substitution.
Substitution, right? Because why?
It's alone and by himself.
Right, they've solved one of the equations for y. So substitution would probably be the best. And then this one, what would be the easiest method to solve this one probably? Would it be graphing? It's hardly ever graphing. And honestly, even substitution is iffy unless you can get that, unless it's easy to solve for a variable, then that's, you do substitution. But, so what's the one that would probably work the best on this one?
Elimination.
Elimination, yeah. And then that's it. So we've actually covered most everything. So I'm going to go ahead and do these two. Did anyone do 65A? Did anyone solve that one yet? So I'm going to go ahead and do it. 65a. So we're going to take this 7x minus 5 and plug it in for y. So I'm going to get 3x minus 2 times 7x minus 5 equals 16. Distribute the negative 2. That would give me 3x minus 14x plus 10 equals 16. 3x minus 14x is negative 11x. Well, this is yuck. Maybe they didn't intend for you to equal 6. So x would equal to 6 divided by negative 11, or negative 6 over 11. And then y would be 7 times negative 6 over 11.
Yeah, some of these fractions I ended up with were very like.
Not nice, not pretty. And that's okay. So I'm thinking they may not have wanted y'all to actually solve this one because it's well, it's pretty gnarly, but that's okay. So this would be negative 42 over 11 minus 55 over 11, which would be negative 97 over 11. That's not very pretty. Doesn't have to be pretty to be right. Most problems, except for in math books, don't turn out very pretty. And then this elimination problem, I have no idea what's going to happen with it. But what would be an easy thing to multiply top and bottom by to get rid of an x or a y?
Well, I picked 12x.
Okay.
Yeah.
So what did you multiply the bottom one by?
Well, it has to be 4 because 3 times 4 is 12. Yeah.
Right. What kind of 4?
Well, I mean, I want to make it negative, but I keep on thinking that I might mess it up. So what I'm doing is I'm just doing it by a positive, and then once I get to the solution, then I just switch all the symbols.
Good idea.
Because I don't know, I'm just thinking maybe I'm going to do it wrong or something like that. I don't know.
Yeah, that's okay if that's what makes you comfortable. So you multiplied it by the 4 and then just make sure that the sign, switch the signs so that, yeah, I hear you. So that's going to be.
But the fractions are like crazy on this one.
Are they? Okay, well, then don't worry about it. Just as long as you know, I think they were just trying to, yeah. They didn't actually say solve it, so.
Yeah, because I mean, I just wanted to see. So I ended up with negative 492 over 132. And then the y was negative 6 over 11. No.
Oh, nice. Yeah, so don't worry about solving that one, but know how to do it. That's the main point. Okay, well, we are through for the day. So I will post all the solutions right now when I get off. So if you didn't have a chance, I know we went through those pretty fast, to get them, they'll be up on Blackboard, and then do the written assignment, the graded assignment, and submit both of those and watch the video for tomorrow. And that's what you need to do for this class. The review for the test is already on Blackboard, so if you want to start looking at that, that would be good too. Matt, you need to tell them anything?
Think it's about it.
Okay. All right. Well, we'll see.
So the review's on Blackboard?
The review is on Blackboard, and the answers are there as well. Yes.
Okay.
Okay. All right. Well, we'll see you guys tomorrow.
Thank you.
Yeah.
Bye.
Thank you.
Have a good day.
Have a nice day.
Thank you. Have a good one.
Bye.